Hi, have a look at this dashboard, Network Anomalies Overview. This is a new feature which we have been working upon in STORDIS. This feature focuses towards detecting network anomalies, whether it is in the configuration of the device or there is something which can be detected from the historical telemetry data, and we can predict some upcoming failures. So let us have a closer look on the dashboard. What you see here are various pie charts. In the first pie chart, you see the anomalies which are by severity. It is showing anomalies by severity, means what part of overall anomalies belong to which severity. Another is anomalies by category. We have various categories which has been identified. For example, best practice category anomaly. Maybe during the configuration you haven't followed the best network configuration practices. Another categories are also like referential, state completeness, and missing config. Another pie chart shows anomalies by type. There can be various types of anomalies. For example, best practice violation, referential integrity related anomalies, protocol state issues, configuration gap, missing critical config, and so on. And here under the pie charts, you see a bar graph which further divides total severities per device. For example, here on the device 10.10.131.111, we are having that many severities, which visually telling you this is the device with most number of severities. Not only that, by the colors, a bar is divided by, you can already sense which kind of severities are sharing which fraction in total severities per device. And below bar graph, you see the overall anomaly database, which has different fields. For example, anomaly type, category, device type, severity. And what we have not seen so far in the pie chart and the bar graph are action, cause, and details about anomaly. So for example, if I try to filter this table with, let us say, configuration gap, okay, and I can further apply filter on different fields. For example, I'm interested in only seeing the medium severity anomalies, and I can further do a filter on the basis of device. Now let us see what anomalies which we have. This is a configuration gap type of anomaly which falls under completeness category, and what it says is this is an action. What action should you take to avoid this anomaly from your device? Add member interfaces to VLAN 15 on your device. Basically, you have created a VLAN and you do not have any member interface for this VLAN. Causes why this anomaly was caused, that's obvious here. VLAN defined without any member. You defined a VLAN but you forgot to add any Ethernet or other interfaces to this VLAN. And here are the details, like VLAN 15 is defined but has no members, and it is further saying that many VLANs are also there which do not have any members. So where this all details are coming from? So yes, there is an AI capable agent which is detecting anomalies for your devices. So it comes with several benefits. For example, if tomorrow you don't want to see a specific kind of anomaly being detected and being stored into the Influx database, for example, do you really need to change the business logic of your application? I mean to say, do you really need to change the code of your application? No. In our agent, by adjusting the prompt itself, the system prompt, which is pretty much written in natural language, you can adjust that prompt and tell it like you do not want to see an anomaly. For example, if I further filter it out for the low anomalies here, and you don't really want to see this assign IP address or VLAN to interface like anomalies, you can specifically mention this in the system prompt itself in your natural language. No code changes or no business logic changes will have to be done in the application itself. So being everything decided by a prompt itself, you can flex the whole anomaly detection system to a great extent. Let me remove the filters. And now you see there are not a big variety of the anomalies in my devices. That may be because of I do not have a lots of configuration, to be specific, malicious configuration on my devices, but you can still detect the various anomalies if they are already there. Maybe you have a lots of configurations on your devices. Maybe out of all those configurations, some are malicious, wrong, or missing. So it can still detect the malicious configurations, like for example the MTU mismatch, which can actually result into the packet drops. Another could be missing or incomplete MCLAG configuration, which might result into the orphan ports, MAC flipping, or even traffic drop. More examples could be like route map or ACL version drift, which will cause like one firewall blocks an SSH traffic but another doesn't. Another example could be overlapping or duplicate ACL entries filling up your device database. How would you detect that? So this kind of system, which is AI capable and read the configuration of your devices for any kind of anomaly. And if you have been a Monsoon user, you already know we have a lots of telemetry data for Sonic devices already. So this is a home dashboard which you can always access using the URL this monsoon.stordis.com, and you will be directly landing on this newly added Network Anomalies Overview Dashboard. If you want to go to further the regular telemetry dashboard, you can click on this thing. So here you will be able to browse through your various devices which are discovered to be monitored, and here are your regular metrics like PFC, LLDP neighborhood, this and that. So the every other regular telemetry related data is still there, just that I have also added a new table. So here you have the device anomalies for this device only, or whatever device you select from the list. So far in our anomaly dashboard, we have configuration related anomalies only, but we are also working on the anomalies which can be detected from the historical telemetry data. For example, CRC FCS error spikes, which indicates a failing fiber or damaged copper cable. How would you detect it? You need to see the packet drops. The packet drop data is already being maintained in a time series in Monsoon already under this interface metrics. There are various metrics about the interface. Another example could be sudden traffic surge on an interface. It could be a DDoS attack, or it could be a backup job which went wrong and resulted into a loop. How would you detect it? Monsoon already have that database being maintained, again in the interface metrics. Another example, if I need to give you, like BGP session flapping, actually it indicates the unstable link. Again, this interface metrics will help us to detect such anomalies and predict the upcoming failures. Another could be high CPU usage on a routing processor. It could be control plane DDoS attack due to that, or it might be too many routes being updated simultaneously, for example, and it could also be a faulty process which results in high resource consumption. Another anomaly which can be detected by the data which is already available in Monsoon is predicting the optical failures. For example, high power usage. It could be due to a fiber bent or dirty connector or optical aging, for example, which really helps you to predict the upcoming failures and outage in your network. For example, this optics related metrics is already being stored in Monsoon in this DOM, digital optical monitoring metrics, and we can use this data to predict the upcoming hardware failures in your optics. And if you really want to move back to your anomalies database, you can click on this home custom button and you will be taken to the home dashboard, which is actually currently the Network Anomalies Dashboard. I hope you like the new feature which we have been working upon, Network Anomaly Detection System. If you want to know more, please feel free to reach us. Thanks for watching.